All right, so we've looked at some ray diagrams, and so when an object is further away than the radius of curvature, we saw what happened. And so this picture from your book shows that we use the parallel axis. So parallel to the principal axis reflects through the focal point. The focal ray, which goes through the focal point and then is parallel to the principal axis, and then the central ray, which goes to the mirror and straight back. So when we described this image last time, we described this as a real image that's inverted and smaller. So we can see that in the diagram. The image here is upside down. The image is smaller, not as tall as the object is, and then we know it's real because the reflected rays actually cross at this point. Okay. Let's see what happens if we move our object around a little bit. So now we're going to go inside the radius of curvature, but not all the way to the focal point. So I'm going to put the focal point on there. Remember, the focal point is halfway between the center of curvature and the mirror. And so if I'm looking and thinking about the rays here, I will draw the principal axis rays, or sorry, the parallel ray, which goes parallel to the principal axis and then reflects through the focal point. So I've got my reflected ray, my incident ray, and my reflected ray. The next ray I'm going to draw is the focal ray. And so the focal ray goes through the focal point and then is reflected parallel to the principal axis. Again, you're seeing my squiggly lines. I know you are using a ruler, so you get a nice image here. Now the center of curvature seems a little weird on this one, but if I go to do the center of curvature line, I have to go through the center of curvature to across the top of the object. So light that comes through the center of curvature and then from the top of the object hits the mirror, and then remember reflects back. And so when I reflect backwards, I'm going to get the reflected ray there. So when I draw my image, I draw it right back here. And so we can say some things about this image. We can see that it is real. I know that because the reflected rays actually cross. And then I know that it is inverted. I see that because it's pointing down and my object was pointing up. It is also larger or enlarged, whichever way you'd like to say that. But here's my object, and I can measure it with my ruler, and my image, when I measure it, is going to be taller. So I have a real inverted, larger image. All right, so if we keep moving, what if we get to the other side? So we've got the focal point here that's halfway between the center of curvature and the mirror. And so I want to draw the parallel ray. So I've got a ray that's parallel to the principal axis, and then it's reflected through the focal point. So with your straight edge, you'll do that. So there's my reflected ray. Now I've got to get a ray that is through the focal point. So this one's a little bit strange, but just like I did last time with the center of curvature, I'm going to bring this ray from the focal point across the top of the object to the mirror. And then it gets reflected parallel to the principal axis. Use your ruler. All right. So I already see a problem. There's no way for this green reflected ray and this red reflected ray to intersect with one another. But let's check with our center of curvature ray. So light that goes through the center of curvature. Here we go. then reflects so that it comes back. And again, yep, doesn't look like that ray is going to intersect either. So I need to know where these rays would intersect. And so in this case, I'm going to draw behind the mirror. And so when I go behind the mirror, I don't want to use solid lines because the light doesn't actually go there. So I'm just going to use my ruler, if I had one, and trace those rays backward. I'm going to need to do that with the green ray here. These are the reflected pieces. And so I need to make sure I'm grabbing the reflected ray, and when I do that, I get an image. So in this case, the light doesn't actually come together here. The light is actually spreading out on the same side as the object. So this lets me know that I have a virtual image. My eye won't be able to detect the difference, but I will see an upright image, and I will see a larger image. So if the object is really, really close to the concave mirror, then I will get a virtual, upright, larger image. This is the classic makeup mirror or shaving mirror. When you buy a makeup mirror or shaving mirror, it has a very shallow curve to it, and when you're right up close, you're actually closer to it than the focal point. Then what you'll see is you get an enlarged image, which is what you're looking for. It's upright, that's nice, you're not upside down. It's virtual, but your brain can't tell the difference, so that doesn't matter to you. But if you do take that makeup mirror or shaving mirror and you leave it on the wall and you back up from it, you're going to notice those other two cases that we just talked about in the previous constructions. So here is the image from your book, and it shows the same things that we drew, but again, we're just emphasizing those pieces, and I'm drawing those for you as you go. So this is the way that your book shows that image. It shows the rays that we drew, and it uses the dotted lines to draw behind the mirror. And we're going to be consistent as we do that. Always draw the dotted lines behind the mirror. And then we see in the picture, you've got the object here, this candle, and then you see the image, and it is upright, and it is larger. We can't tell by looking if it's virtual or not. We have to do the ray tracing to know if it's virtual. So that takes you through the three cases for a concave mirror. You'll want to practice with those. And next we're going to look at some mathematical ways to represent these same ray diagrams. Have fun with those. Make sure you use a ruler.